Hello, everybody. I'm Joshua. I'm the dev advocate slash dApp developer on Phala Network. Typically, my responsibilities are the palette integration for Phala World, and then building dApps and teaching people how to build dApps on top of our network with Phat Contracts. So this talk will kind of like go into like the next major step in replacing Web 2 with Phat Contracts. But First, I want to address like 3 topics today before we kind of like dive into the technology, because sometimes it can come a little fast and be a little too much. So we're going to dive into like the issues in smart contracts, why we need smart contracts, what are the good things about smart contracts, and what does a possible future look like. So at the end of this talk, I'm hoping that you can come away with seeing that you can answer these questions here, understand what the smart contract industry looks like as it is today, and then just kind of understand where the future will lead to. So going into the issues that are in smart contracts today. So typically, I'll talk about just kind of like the first to market and the EVM and how EVM layer ones dominate the industry in general. There's a lot of tooling, a lot of developers, a lot of templates, and smart contracts are the tooling is very robust for developers to get started and started quick, but the technology and the EVM is kind of like targeted for a specific use case. And there's not a lot of flexibility, and you're sort of at mercy of the on-chain consensus. And from there, you're not able to really, you're going to have like this latency whenever you're making requests, and there's not a lot of storage that you can use, and there's not a lot of optimizations as well. And this is why kind of I'll lead into the next slide after this one about WASM smart contracts. But to move next, closed system. So you don't have internet access. You can't make any HTTP requests. If you want to integrate like an Oracle or VRF, typically it's going to take a long time. And I believe there's 12 EVM chains with Oracle's integration. And then outside of that, you're kind of compromising on decentralization and kind of really attacking a really hard problem that can take a lot of time and a lot of effort if something breaks as well. Next, expensive and deterministic. I kind of went into the deterministic part on the part 1, but as you can see on like Ethereum, like transactions are pretty expensive, and it doesn't really make sense to deploy smart contracts on Ethereum if you want to run some kind of decentralized application for your enterprise businesses. It just doesn't make sense. It's too expensive. So confidentiality, everything is public on the blockchain. So typically most chains don't have a privacy preserving solution, and a lot of the privacy preserving solutions are limited as well because they're still building towards like that EVM based model and not really innovating towards something a little different today. Centralized compromises. So now when I was speaking about earlier saying that you're kind of limited by these smart contracts, well, now people, they want to build a game, or they want to build some kind of computation intensive task, or they want to store their NFT somewhere. Most of them are going to opt for a centralized service for their computation. And this comes with being able to have like a single point of failure, and you're really sacrificing on a true decentralized app in this Web3 world. So it's not really Web3, it's like a Web2-ish 0.5. So, and then the last part, internet access. I had mentioned this earlier. Chainlink is the standard for Oracles and VRF. Integrations in general take a long time, and the work is pretty complicated for chains with different consensus mechanisms, or if they have like a different architecture, it's a little harder for them to get from announcement to actually deploying the product so that you can actually work with it as a dev. So this is kind of like a high level diagram of what's going on here. So when I say like you're sacrificing for these centralized services, you're using AWS cloud, Microsoft Azure, and you're either using that for like even here on the back end, some people like you'll see some NFT collections in general using centralized storage to do their mints, and it's that's not an NFT, right? Yeah, so it's just a file, but the same thing with a file system as well. But yeah, so moving to the next slide. So I know I like mentioned some negatives about smart contracts, but there are a lot of positives and why we need them moving forward. So smart contracts are permissionless dApps, so they truly are unstoppable. I mean, the only thing is if everything's public, then you can have node operators kind of be at mercy of regulation and being kind of forced to bend the knee essentially, and then you can have all your accounts flagged if you're like playing with Tornado Cash, which is unfortunate. But another a nice positive though is like the wins of WASM. So WASM's coming. So WASM smart contracts. WASM in general is gonna be, I don't know. It's hard for me to like really just like get the excitement out, but essentially we're gonna have a lot more robust and incredible dApps being built on platforms like Gear or Astar Network or Phala Network with the ink-based smart contracts. And then you also see other ecosystems like Cosmos with COSM WASM, and I believe like Dfinity with their canisters and their WASM canisters. And it's really a positive for developers in general because you have a lot of language support, you have some libraries, you have and then you also compile down to WASM, which is supported by all the major companies, and you're going to have the 64 and 32-bit operations at your will. So there's a lot more flexibility for innovation, and then people are going to be able to get really creative whenever they're creating these standards. So next, programming in Rust. I mean, it's awesome. I started programming in Rust this last year, and I love it. It makes developers better developers, and there's extensive support and libraries that you can utilize, and it's just an incredible language in general. So immutability and intermediaries. So all smart contract states and their transitions are immutable on the blockchain, so you can't change it. You can't change the blockchain state. So that's something that's a positive that could be that is definitely needed, because you can see like in today's world there could possibly be somebody that gets access to the database. Either they encrypt it or they want to change data, whichever, like the kids trying to hack into the system, get an A instead of that F. But it's this is where like smart contracts can really like help out here. And then some really exciting things like automation and cross-chain smart contract interactions, like through XDM, and I believe like Oak is doing some really cool things with automation, which I think is some stuff that's just not really out there right now. You have some like automation like with the EVM dApps out there, which are really cool. Like they're starting to create these like schedulers and triggers and all that, but it's still like a work in process. They're still kind of limited by the EVM. But even though I list all these positives, we still have this missing gap, right? This missing gap of you have to, if you want internet access, you need to integrate a long time, and you have to get on the list to the number one like Chainlink market competitor, or if you can go to another Oracle service, but you might be sacrificing some things that you really do want on your system. So this is also like a limitation. We also don't have confidentiality still, so this is something that's lagging as well. And then in general, the last step was your computation is not very scalable. You're still limited, and this is for even with WASM coming out, you're still limited by your computational tasks. So, what is a possible future that we see? And this is kind of where things start to get a little exciting, because now I'm gonna introduce to you like a Phala Network, a decentralized, privacy-preserving cloud computation protocol. And we use hardware-based encryption with the secure enclaves to be able to, one, create this off-chain computing model that allows us to, one, you have the Phala blockchain, you have your off-chain secure enclave workers, and you have a message relayer that's encrypted end-to-end, so that you can run these Phat contracts that we call, because it's after the protocol for like Phat applications. So moving here, so like in today's fit, right, we're missing with the Web3 like backend specifications. You want it to be blockchain native, no loss of state, low latency, which right now, like I mentioned earlier, we're having to wait 6 to 12 seconds. Continuous service, so no lifetime limitation on your contracts, and then also connectivity to the internet. So now we're starting to approach on something that's the most valuable thing, I think, with the Phat contracts running in these off-chain secure enclave workers, is now you have access to the internet. So the diagram that I showed earlier was where we are compromising using these Web2 services and centralized services, but now this is kind of where Phala Network and the Phat contracts kind of reside. So now we can use these Phat contracts kind of as a decentralized Web3 Amazon, like AWS Lambda, essentially. And now we've already made some proof of concepts that are out there right now, and you can build on our testnet. But you can, one, since these are running inside the secure enclave, you can store any kind of private data. So this is where we're kind of we are solving that confidentiality issue. And since we have HTTP requests, now we can access the internet and then say you want to use Arweave, you want to use IPFS, Filecoin, or if you care to use like a Web2 service, you can use AWS S3. So you have access to be able to populate these databases with the Phat contracts HTTPS calls. So now you're starting to see like, okay, now I can connect storage. What about other Web2 services? Well, now you can use the HTTP request to be able to run a bot for Twitter, run a bot for Telegram, get data from other HTTP endpoints, and so on. And then one of the like really exciting ones is now, since you can interact with any endpoint, so you can potentially, one, interact with the RPC node, get the like for instance for like Substrate, you can get the runtime version. You can get the next nonce for a derived account key pair within the Phat contract. You can then get the Genesis hash, compose an unsigned extrinsic, sign it with that derived key, and then send that to an RPC node and be able to execute a transaction. And these are like kind of like the steps of truly building like the glue that is missing between Web 2 and Web 3. It's now we're starting to get towards this actual 2.5 that can scale and really serve the needs of any kind of business out there right now. So this is kind of giving you an example of like Phala Network's Web3 computation infrastructure. I hadn't mentioned it earlier when I was just moving with my hands, but go next. Yeah, and this is our secure enclave technology. We have our hardware-based encryption here with CPU level isolation. So now you're not going to have any kind of untrusted code interacting with like being able to see or know the contents within the secure enclave. So we're able to utilize this to create these different clusters in our network, so that say if you want to run a mining a bunch of miners on our network, well, you can deploy a cluster. You can deploy your own runtime bridge, which would be that message relay layer between the Phala blockchain and your miners. And you can then, after that, kind of set the price for the computational resources that you will provide for the developers. So the developers will be able to go and stake, get their computation, build their products after they're done, unstake, and then sort of the only transactions fees seem to be like transactions right now, but we're still working on the finalization of these tokenomics before we go to mainnet. But we're really excited because the release for the initial like V1 Phat contracts is coming soon. Yeah, I've like explained it, but going forward, like what is Phat contracts programming model? Like no gas fee, that zero latency because all the off-chain secure enclave workers are in sync with the Phala blockchain, so they have the state right away. So that's once you send that query, it's instantaneous, and also it your HTTPS requests, they're executed through queries, so they're happening right away. You're not sending a transaction to store something on another storage. You're just sending the request, goes right away. You'll see the database population whenever you can query and verify that. And this kind of goes into like the missing computation unit for smart contracts. As I mentioned earlier, that 6 to 12 second latency for smart contracts, you're only going to get the computing power of one node. And while Phat contracts are going to be scalable, your privacy is preserved through the secure enclave, and you have internet access. So now you can actually build an Oracle service or a VRF service for another chain, and the integration is not going to take as long as it is to get on the waitlist for Chainlink. So here, I had mentioned this earlier about being able to interact and transact with other chains. So now with these Phat contracts being able to interact directly with other blockchains and their RPC nodes, like I had mentioned earlier, you can compose these extrinsics, sign them with the derived key pair within the Phat contract, and then send it to the destination chain. There is like a caveat there, like where maybe like within a cluster there's too many nodes they're all sending the request to the RPC nodes, and maybe you don't want the transaction to happen more than once. So this is where we've started to develop this like off-chain roll-up architecture, and this is something that we'll be able to like control that synchronous transactions for the transactions that you'll send. Connect chains and services. So like I was mentioning earlier, you can connect to Arweave, you can connect to the graph, you can interact with RPC nodes from different networks, you can interact with Web2 services, use Web2 services, just really be that middleware. Oops. And then a really interesting one for storage, you can also then derive a key pair within the Phat contract as well, and then use that to encrypt your files and then store them in the off-chain storage, whether that's decentralized storage like Arweave or IPFS or AWS S3. So, and do you have questions for me? So, yes. Oh, well, I mean, we're not, so so the question is just, so we're talking about ISPs, like internet service providers, and the networking infrastructure that allows us to like communicate between each other around the world internationally. And usually, I believe like fiber cables are like allow this to be really fast. I don't see that, like that's not what we're solving. That's not the problem we're solving. Where it's the internet connectivity to each other in a decentralized way. There are like I believe there's some products out there that are trying to attempt this, like I think it's like Packet Cash from like like I don't know if they're in the Cosmos ecosystem or not, but I know there's some like Cosmos like blockchains that are doing a lot of kind of really cool things with IT infrastructure. I don't know too much about it, but I know they're doing some things like that. For instance, there's another one that's like propagating like 5G and Wi-Fi so that you can get it to remote areas in a decentralized way. And then there's Helium that's like a little centralized. And yeah. Yeah, yeah. I mean, yeah, yes. Okay, so the question is just kind of what nodes that can run on our network and what are the requirements from the hardware perspective. So right now, we support Intel SGX chips only. So in the future, we're going to extend to like AMD SEV, ARM Trustzone. But essentially, you'll need a miner that will be able to submit a attestation. So you'll generate a quote with your chip. Then Intel assigns a key to each chip in the hardware, and then they're able to then generate a quote, get like the BIOS hardware, so that and the version of code that you're running, so that we can create this confidence score essentially. And based on that, it's like 1 through 5. It'll give you the ability to run different types of computation. So another thing about this, when you're running a miner on our network, 70% of our token allocation goes to the miners. And this is interesting because we also allow them to create these staking pools. So now you can either, if you want if you want any user to stake behind your pool, then you can set like a cap on the amounts of tokens you get, or tokens you can have contributed, and anybody can contribute, or you can close it off and control it for your own. And in the future, there'll be like systems contracts for you to kind of like control what access, like an access control feature for your mining cluster. So these are it's sort of just like allowing people to build their own data center, but then also they're not able to like peek inside and see what is running within these applications. So that's like a really interesting part there. Yeah, I like something that I was talking about with one of the like a machine learner researcher. For me, I don't know much about machine learning, but he was like really interested in being able to preserve his model and ensure it's like not stolen by deploying it in these Phat contracts, because you can't what's it say? How do I say this? You can't look at the Phat contract without being the owner and understanding having the contract ID to be able to interact with it. So you can really close off people from stealing your IP essentially. And some interesting things with like Invarch is like doing some really cool things as well with us working with the Phat contracts and their integrations. A really cool one too would be encrypted storage for different businesses, or just utilizing using that decentralized storage. Or another thing would be using encrypted NFTs in a way to create some type of file storage. I believe that's also something that Invarch is doing as well. There's a lot of like really cool use cases you can do. I just want to I want us to go mainnet so I can start seeing like, wow, these are some incredible things I wouldn't even think about. And I think another major use case is just building a fully decentralized Web3 stack. So yeah, so the side channel attacks. So one, we have like a nominated like a proof of stake protocol, but we're able to one elect these gatekeepers essentially, and these gatekeepers will then they'll go through the key rotation algorithm that we have implemented, so that they can agree upon a sealed key, and then be able to make that the root key, and then that root key will be able to create these like a contract key for that for different clusters to be able to generate a contract ID and encrypt the state of these Phat contracts. So essentially, if you're able to do a side channel attack, it's usually going to be within one cluster, and we'll have like multiple clusters. So like you're really like affecting like a small cluster within the entire network. So you're not like really it's like you have to target the exact CPU, be outside their house, understand what they're doing, and then like it's just like a really difficult way to attack the network, and it's not really feasible essentially. And then that's also part of the attestation process is we're able to like ensure like not like through this process we're not going to have any kind of like fake signed quotes to go through and want to get approved by the Intel attestation service. But I don't see side channels in general being a problem for the network. It would be like a problem if we were something like similar to maybe I guess a good example is like Secret Network hasn't succumbed to a side channel attack, and theirs is their computation model is on-chain computation. So if they were to leak a key within the enclave, then that could take down the entire network possibly. But I don't know it too well, like and from an architecture perspective. But I don't see it as a big problem. No problem. Cool. Thank you.